Welcome to T1 Academy. In our last sessions, we have seen this how to find the units, digit and number of zeros things. So, in this session, we are going to find what are the remainders with the help of remainder theorem, and we will also see the Euler's remainder concept. Why? Because students, nowadays only learning the remainder theorem is not sufficient. They are asking us questions based on Euler's remainder. What is this Euler's remainder and how we need to find the Euler's remainder and everything we will see in this session. Okay, now, so first of all we will see what is this remainder theorem. So there are some basic rules for this remainder theorem. We will try to observe those reminders, that rules. See here, what is the first rule is, for example, if I want to find the remainder of some 172 into 143, 172 plus 143, 172 plus 143 divisible by 5. If I want to find the remainder for this, the general procedure for this one is what? In general is 172 plus 143. You will add these two things. What you will get here? 200 and, okay, exactly divisible, right? Okay, no problem. 315. What we will get here? 315 by 325 by 325 by 5. What we will get here? 325 by 5. And the remainder for 325 by 5 is what? 0. And you will say that your answer is here 0. Okay. Now, what the remainder theorem tells us is that we can find the individual remainders. We can find the individual remainders and apply the mathematics. What is the remainder for 172 by 5? The remainder is 2. What is the remainder for 143 by 5? The remainder is 3. What is the mathematical symbol between them? Plus. So what you will do? 2 plus 3 and you will write your answer as 5. Now before that, see here students, when you divide a number with 5, what is the highest remainder possible? 4, right? 4, right? So what are the possible remainders? Tell me. Possible remainders are 0, 1, 2, 3, 4. 5 means what? Once again 0 only, right? 5 means what? You will once again divide it with 5 and you will write your answer as 0. So when you divide a number with n, when we divide a number with n, the highest possible remainder, will be what? Remainder is n minus 1. When you divide a number with n, the highest possible remainder for us is n minus 1. That means for your example, if you divide a number with 9, the highest remainder possible for us is 8. When you divide a number with 20, the highest remainder possible for us will become 19. For example, in doing so, we get a value which is equal to or greater than our given divisor. See here students, for your knowledge sake, I will explain you the terminology. We will call this as a divisor, dividend, quotient, and this one we will call it as remainder. Understood students? Divisor, dividend, quotient and remainder, for your knowledge sake. Okay. So when you divide a number with, our remainder will be always less than the divisor. Remainder should be always less than the divisor. If you get a value greater than the divisor in like this, what we will do is, in general, we will once again divide it with the divisor. Like this we are going to find. So the first principle of our remainder theorem is, the general observation is, first one is, when we divide a number with n, the highest possible remainder is n minus 1. This is the first thing. And next one is, we can find the individual remainders and apply the mathematical symbol between them. For example, if I have plus, we will take plus. If we have into, we will take into. Similarly, for the same example, if I have something like this, 172 into 143 by 5. What is the remainder for this? 172 into 143 by 5. What is the remainder for this? 2. What is the remainder for this? 3. So 2 into 3, what I will get here? 6. But will my answer be 6? No. Why? Because when I divide it with 5, the highest remainder which I should get is 4. But according to this, what I am getting? 6. So once again divide it with 5. Once again divide it with 5. So what is the remainder you are going to get here? 1. Remainder is 1. So the remainder for this value will become 1. So whenever you have any huge product or any sum or anything like this, usually find their individual remainders. Find their individual remainders and apply the mathematical symbol between them. This is 2 basic rules of our remainder theorem. What is the next rule is, see here, if I divide some 18 with 5, what is the traditional way of finding the remainder? What we will do? 18, 5 3s are 15 and the remainder will become what? 3. This is the method which we will do in our general process. But can I do in this manner or not? 5 4s are 20. So when I subtract it, actually we will get 3 by subtracting only, right? So when I subtract it, what I will get here? Minus 2. Why cannot I do like this? Yes, we can also do like this. There is no wrong in that. So actually students, you can do like this. 5 4s are minus 20 and you can take it as minus 2. Practically speaking, both 3 and minus 2 are correct. That means negative remainders are also possible. But when you tell your final answer, you should always tell a positive number. Because of that reason, how we will convert this negative into positive means 5 minus 2 will become what? 3. Once again the same answer we will get. That means while solving the problems at intermediate level means at the middle stages, you can take negative remainders. In the middle stages, you can take the negative remainders. But when you write your final answer, always we will convert it into a positive one and then only write the answer. What is the use of these negative remainders? We will see later. But negative remainders are also possible. We can use them in the intermediate level. But when we write our final answer, we will always convert them into a positive one and then only write our final answer. Okay. So the third principle of this remainder theorem is negative remainders are possible. But when we write the final answer, we convert them to positive, to a positive value. Okay, at the intermediate levels, we can have negative remainders, but when we write the final answer, we should always convert them into a positive one and then only write our final answer. In this manner, we are going to write these negative remainders. We are going to find we take the help of negative remainders. Okay, sir, good. Where we will see these negative remainders, where these negative remainders are helpful, we will see now. Next. Okay, 3 principles understood, right? Our remainder should be always less than divisor. That is the first rule. Second rule is we can find the individual remainders. And apply the mathematical symbol between them. And the third rule is we can also have the negative remainders in the intermediate level, but when we write the final answer, we should always convert them into a positive one and then only write our final answer. These are the 3 rules in our remainder theorem. Okay, good, super. We will see some examples now. Find the remainders of the following. First one, 6. Next one. It is up to you, choose whatever the values which you want, you can choose them. No, there is no wrong in that. We will see now. Fine. We will see some random examples, students. What will happen? 174 by 6. What is the remainder for 174 by 6? It is 0. Okay. So anyway, we will get 0, right? It is waste of time. So I will take 173 for better understanding. Okay, 173 by 6. What is the remainder? If you take a positive remainder, you can take plus 5, or if you want to take a negative remainder, you can take it as minus 1. Anyway, positive remainders you people know, you will do it, but negative remainders we will take. I will take minus 1. 176 by 6. What is the remainder I will have here? I will take a positive one, that is plus 2. Okay, 175 by 6, what is the remainder I will have? Plus 1. Plus 1. Why? Because 174 is exactly divisible by 6. So, what I got at last? Minus 1 into 2 into 1. So, what it becomes? Minus 2. This is my final answer, right? So, I cannot write it in the negative value. So, what I will do? 6 minus 2 and I will write my final answer as 4. I will write my final answer as 4. If you take all the positive values also, there is no wrong. If you take all the positive values, what you will get here? 5. 5, right? So, 5 2s are 10. When you divide a number with 6, is there any chance to get 10? No. So, once again you will divide the 10 with 6, you will get the remainder as 4 only. Okay, understood? So, you can take positive or negative, it is up to you, you will get the same answer. Now, similarly 184 by 5, what it is? Minus 1. Next 179 by 5, what it is? Minus 1. 146 by 5, what is this? Plus 1. So, minus 1 into plus 1, what you will get here? Plus 1. So, the remainder is, final answer also becomes 1. Why? Because minus into minus, plus, plus into plus, plus. So, at last you will get the answer as 1, the remainder as 1. Understood, students? Like this, we can find the remainders by taking the help of individual remainders. Okay, well and good. Now, where these negative remainders are helpful for us means the questions of this type. See here, students, especially questions based on powers. Powers. What will happen in the case of questions based on powers? See here, if I want to find the remainder for, what is the remainder for 7 to the power of 49 by 8? What is the remainder when 7 to the power of 49 is divided by 8? What is the remainder? So, for time being, forget about the power 49. No need to worry. Simply write the remainder between 7 and 8. What is the remainder for 7 by 8? If you don't know negative remainders, you will say answer as 7. Remainder for 7 by 8, if you don't know the negative remainders concept, you will say the remainder will be 7. But now you know the negative remainders concept, right? Now tell me what is the remainder for 7 by 8? 7 by 8, what you will get the remainder? 7, when I divide it to 8, 8 ones are 8. So, when I subtract it, what you will get here? Minus 1. So, the remainder is minus 1 and I have a power as 49. So, minus 1 whole to the power of 49, what is the remainder what I will get here? Minus 1. Will minus 1 will be my final answer? No. We should not write my final answer in negative manner. So, what I will do? 8 minus 1. It will become what? 7. So, the remainder for 7 power 49 by 8 is 7. So, the negative remainders will be helpful in this type of cases. Understood, students? So, we can take the help of negative remainders in this type of cases, especially in the case of powers. Okay. Next, similarly, please tell me what will be the remainder for this one? Some 24 to the power of 56 by 25. 24 to the power of 56 by 25. What is the remainder I will get here? 24 by 25. What it is? Minus 1. Whole to the power of what? 56. Even power, right? Minus 1 whole to the power of even power means what you will get? Plus 1. So, anyway the positive answer. So, no need to convert or do any subtraction and these are the things. So, when I divide 24 to the power of 56 by 25, what is the remainder I will get here? 1. What is the remainder I will get here? 1. Okay. In this manner, we will take the help of negative remainders. We will take the help of negative remainders. Now, similarly, see here, students, for example, if I want to find the remainder for 48 to the power of 73 by 49. 48 to the power of 73 by 49. What is the remainder for 48 by 49? This will become what for me? Minus 1 whole to the power of 73. Means what it becomes? Minus 1. But minus 1 will not be my answer. So, 49 minus 1, what it will become? 48. So, my answer will become 48. My answer here becomes 48. And similarly, 35 to the power of 48 by 34. If I want to write the remainder for this, 35 by 34, what is the remainder? Plus 1. To the power of 48, 1 only. No need to worry with this positive remainders. 35 by 34, what is the remainder? You will get 1. And 1 to the power of 48, you will get 1. So, in most of the cases, we can write the difference between numerator and denominator as either plus 1 or minus 1. It doesn't matter for us. We can write it as plus 1 or minus 1 and we need to solve them. Now, we will see some of the different questions from this one. Okay. Euler's remainder, later we will see that Euler's remainder. But meanwhile, please see this one, students. We will see the Euler's remainder later. Okay. Now, what will happen in our general cases means, So here if I want to find the remainder for, 2 to the power of some 27 by 7, if I want to find the remainder for this. Now what we will see, if you take the positive remainder, it will get 2. If you take the negative remainder also, you will get minus 5. Anyway, there is no chance. But please observe, is there any power of 2 nearer to 7? Any power of 2 nearer to 7? Yes. What it is? 2 cube is 8. So instead of 2, if I have 8 at the numerator, it will be easy, right, for me. Why? Because the difference between numerator and denominator becomes 1. Then easily you can write the answer, how we have written the previously. So in these cases, intentionally what I will do is, I will write this as 2 cube whole to the power of 9 by 7. I can write, right? A to the power of m whole to the power of n means a to the power of m into n. So 2 cube whole to the power of 9 by 7. Okay, good, superb. So what happens to this now? 8 to the power of 9 by 7. 8 to the power of 9 by 7. So what is the remainder for 8 by 7? It is 1. 1 to the power of 9. So my answer will become what? 1. So whenever you see this type of questions, try to write the difference between numerator and denominator as 1 by splitting the powers. If you try to solve the difference between numerator and denominator as 1 by splitting the powers, you will get the answer very effectively. Okay, similarly, now please try to observe and tell me the answer for this. 2 to the power of some 40 by 33. 2 to the power of 40 by 33. Which power of 2 is nearer to 33? 2 to the power of 5 is what? 32. 2 to the power of 5 is what? 32. So that means I need to split in the powers of 5s. So now tell me how I can get 2 to the power of 5 here. 2 to the power of 5 is what? 32. Okay, good, superb. Then how I need to write this one? How I need to split this 40? 5 8s are 40, right? 5 8s are 40. So what I will write this as? 2 to the power of 5 whole to the power of 8 by 33. By 33. Okay, good. So now what happens to this? 32 power 8 by 33. 32 power 8 by 33. So what is the remainder for 32 by 33, students, here? Minus 1. Minus 1. Minus 1 whole to the power of 8. So it will become anyway plus 1. No need to convert anything or do any other values. So the remainder for 2 to the power of 40 by 33 is 1. 2 to the power of 40 by 43 by 40 by 33 is 1. Okay. Now similarly, what is the remainder for 7 to the power of 53 by 50? 7 to the power of 53 by 50. What is the remainder for this? If anyone asks me this question, then how we will find this value? How we will find this value is, tell me which power of 7 is nearer to 50? 7 square is 49. So I need to split in terms of 7 square. So my requirement is 2 and I need to divide 53. Why? Because I have 53, my requirement is 2. 2 26 are 52 and the remainder is 1. And the remainder is 1. That means how I can split this one? 7 square. Why I am writing 7 square? My requirement is here 7 square to the power of 26 into that remainder power. I will write it separately. This one is the remainder, right? I will write it separately. Why? Because in our previous two examples, they are exactly multiples. So there is no issue for us. But here they are, 53 is not an exact multiple of 2. So I need to split it. So how I can split? I will divide 53 with 2. So 26 will come to numerator and this remainder will go separately by 50. So now what happens to this? 49 to the power of 26 into 7 by 50. 7 by 50. So now the remainder for 49 by 50 is what? Minus 1 whole to the power of 26. And the remainder for 7 by 50 is what? 7 only. The remainder for 7 by 50 will become what? 7 for me. The remainder for 7 by 50 becomes 7. Okay. So minus 1 whole to the power of 26 is 1 into 7 is 7 only. So my final answer will become what here? 7. Sometimes the power we cannot split as the exact multiples like this. So in that cases we need to split by ourselves. So how you need to split? Just now I have shown you. In this manner you need to split the powers and write it. Okay. Now we will see some other examples, students. What we can do is 3 to the power of 44 by 28. 3 to the power of 44 by 28. Okay. Please try to solve this one. Pause the video and try to solve this one. First of all, split the powers and then do it. What is our requirement here? 3 cube is 27. So 3 times means 14 3s are 42 into I will be left with 3 square by 28. Okay, how I have split it? In previous slide we have splitted the powers. Please do in the same manner. So what I will get here? 27 to the power of 14 into 9 by 28. So the remainder for 27 by 28 is minus 1 whole to the power of 14 into 9 by 28 is 9 only. So minus 1 whole to the power of 14, it will come plus 1 into 9. This will become 9. So the remainder for 3 to the power of 44 by 28 is 9. 3 to the power of 44 by 28 is 9. In this manner, we are going to solve the problems. See, the first and foremost thing, we can take the negative remainder help. Okay, if the difference between numerator and denominator is either plus 1 or minus 1, we will take that one directly. If not, we will split the powers in such a manner that the difference between numerator and denominator is either plus 1 or minus 1. That is the next stage. Understood? And the third one is, this is the case. We will split them and we will have one more example under this one only, students. For example, if I want to find what is the remainder for 2 to the power of 83 by 83. Okay, this type of questions, nowadays they are asking this type of questions, students. 2 to the power of 83 by 83. Now, first thing what we will do is, we will check what is the power of 2 which is nearer to 83 in general. So, what we will get here? 2 power 1 is 2, 2 square is 4, 2 cube is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, 2 to the power of 6 is 64, 2 to the power of 7 is 128. Is there any power of 2 which is nearer to 83? Is there any power? That means you can write it as plus or minus 1 here. No, we cannot write here as plus or minus 1 here. Plus or minus 1 here. So directly we can take here as like this one. Okay, 64 or 128. 64 or 128. There is no other chance. We cannot take 83. There is no power of 2 which is nearer to 83. Then how we need to solve this type of questions? How we need to solve? See, if we were able to write the difference as plus or minus 1, it is very easy. We will do it. But these are the questions which was asked previously. But recently they are asking us this type of questions. Then how we are going to solve this type of questions means with the help of a remainder called Euler's remainder. We will take the help of Euler's remainder. Euler's remainder. What is this Euler's remainder? And how we are going to get this Euler's remainder, we will see. Euler's remainder, this property says that the remainder for a to the power of b or else a to the power of what we can say a to the power of p. A to the power of p by b is 1 if it requires two conditions. First condition is a comma b are co-primes. The first condition is a comma b should be co-primes, and the second condition is here is p should be a multiple of Euler number of b. P should be a multiple of Euler number of b. The denominator is Euler number. P should be a multiple. That means it should be in multiples of Euler number of b. Now the most important thing is what is called this Euler number. What is called this Euler number? If you understand this Euler number, their entire Euler's theorem is done. The only thing is how we are finding this Euler. So what is called this Euler number? Euler number. What is called this Euler number? With an example, we will try to learn it, students. Why? Because with the statement, we may not understand exactly. After writing the example, then we will write a statement for this one. Euler number means, for example, if I want to write the Euler number for 12. If I want to write the Euler number for 12. So what I will do is, I will write all the numbers below 12. What are the numbers below 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. I will write all the numbers below 12 and I will check how many co-prime pairs I will form with 12. See, 12 and 1. Co-prime pair means what? HCF should be 1, right? So the HCF of 12 and 1 is what? 1. So with 1 I can form a co-prime pair. With 1 I can form a co-prime pair. 12 and 2, what is the HCF? 2. So 12 and 2 are not co-primes. 12 and 3 not co-primes. Why? Because their HCF is 3. 12 and 4 are not co-primes. Why? Because their HCF is 4. 12 and 5, yes, these two are co-primes. Why? Because the common factor, the highest common factor between 12 and 5 is 1. 12 and 6 not possible. Why? Because the HCF is not 1 between 12 and 1. 12 and 6. 12 and 7, yes, 12 and 7 are co-primes. 12 and 8 are not co-primes. Why? Because HCF is 4. 12 and 9 are also not co-primes. Why? Because HCF is 3. 12 and 10 are not co-primes. Why? Because HCF is 2. 12 and 11 co-primes. Then the HCF is 1. HCF is 1. So that means how many co-primes pairs are forming with the numbers below 12? 1, 2, 3, 4 and 5. So the Euler number of, so not 6, 6 is not there, sorry, 6 is not there for us. So how many are there? 1, 2, 3 and 4. So the Euler number of 12 is how much for us here? 12. So the Euler number of 12 is 4. That means Euler number means nothing but the number of co-prime pairs a number can form with the numbers less than the given number. So we need to find the number of co-prime pairs with the numbers less than the given numbers. Then that will become the Euler number of that given number. That means for 12 the Euler number will become what? 4. For 12 the Euler number will become what? 4. Understood, students? Sir, as the number is very small, you calculated the Euler number very easily. For example, if the number is something like this, what we can say is sum 120. How we can find the Euler number? For 12, you easily calculated the Euler number. But if it is 12, 120, we cannot write all the numbers and we cannot find, right? How we will do that one means, see here students, for that we have a shortcut technique. See, actually 12, what we can write? Do the prime factorization for 12. Prime factorization is very important. That is the reason in my first session itself I told you prime factorization. When you do prime factorization for 12, what it becomes here students? Please observe. 2 square into 3, right? 2 square into 3. So what I will do is the Euler number of 12 is 12 into 1 minus 1 by 2. This is 2. And 1 minus 1 by 3. 1 by 3. Irrespective of the power, whatever may be the power, if the numbers are there. For example, if 5 is there, I would have written 1 minus 1 by 5. Okay. So what happens to this? 12 into 1 by 4 into 2 by 3. 2, 4 3s are 12, 12 will get cancelled, right? So what you will get here? 1 by 2, sorry, 1 minus 1 by 2, here you will get 2, 2 3s are 6, 2 2s are 4. So the Euler number of 12 is what? 4. Like this will. Sir, why we are doing 1 by 2, 1 by 3 means very simple, ma. If 12 is not a co-prime with 2, if 12 is not co-prime with 2, that means all the multiples of 2 are also not co-primes with 12, right? Am I correct or not? Please observe here once. 2 is not for a co-prime with 12. Then all the multiples of 2, what we have? 4 is not a co-prime with 12, 6 is not a co-prime with 12, 8 is not a co-prime with 12, 10 is not. That means every second one will be by default will be deleted, right? So 1 minus 1 by 2, half of the numbers are deleted. Next, if 3 is not a co-prime with 12, then every third time is also not a co-prime with 12. So 1/3 of numbers will be deleted. So that is the reason 1 minus 1 by 3. Based on that logic, we will do in this manner. You don't require that. Simply do the prime factorization 1 minus 1 by 2 and 1 minus 1 by 3. Why we are doing 1 by 2 and 1 by 3 means this 2 and this 3. Now we will go for Euler number of 120. How we will find the Euler number of 120? See here students, what I can write? 120. Do the prime factorization for 120. What you will get? 2 60s are, 2 30s are, 2 15s are, 3 5s are. Okay. So what 120 I can write? 2 cube into 3 to the power of 1 into 5 to the power of 1. So the Euler number of 120 will become 120 into 1 minus 1 by 2, this 1 by 2, into 1 minus 1 by 3 into 1 minus 1 by 5. 1 minus 1 by 5. Why? Because in this video we also have 1 by 5 here. In this video we also have 1 by 5 here. So now what happens to this? 120 into 1 minus 1 by 2 is 1 by 2. 1 minus 1 by 3 is what you will get? 2 by 3. 1 minus 1 by 5, what you will get? 4 by 5. 4 by 5. Now cancel it. What you will get? 2 3s are 6, 6 5s are 30, right? So 34s are 120. Now 4 2s are 8, 8 4s are 16, sorry, 8 4s are 32. 8 4s are 32. So the Euler number of 120 is 32. That means if you write all the numbers below 120, that means 1, 2, 3, 4 up to 119. If you check with each and every number, you will get 32 pairs of co-prime pairs. You will get 32 co-prime pairs. So the Euler number of 120 will become what? 32. 32. Okay, understood. Well and good. Now students, tell me, from these concepts we should draw one important thing. What is the Euler number of a prime number? Any prime number. Let that prime number be n, or else a, or else p, whatever it is. Let the prime number be n. Tell me what will be the Euler number of that prime number n minus 1. Am I correct or not? For example, if I want to write the Euler number for 5. Euler number 5, what I will do, I will write all the numbers below 5. Anyway, while learning the co-primes concept itself, if one of the numbers is prime numbers, obviously the pairs will become what? Prime numbers only, co-primes only, right? So 5 and 1 will become one co-prime pair, 5 and 2 co-prime, 5 and 3, 5 and 4, all will become co-prime pairs. If I want to write the co-prime pairs for 11, or else Euler number for 11, what I will do? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. If you check with every number, it will become co-prime only. So that means the Euler number of 11 will become what? 10. The Euler number of 5 will become what? 4. That means Euler number of a prime number n will become n minus 1. Okay. Why? Because it will form all the co-prime pairs with all the numbers below it. Okay. So from this what we can say is the Euler number for a prime number n is n minus 1. The Euler number of a prime number n is what for us here? N minus 1. N minus 1. That means what is the Euler number for 17? 16. What is the Euler number for 29? 28. What is the Euler number for 31? 30. What is the Euler number for 37? 36. Like this. The Euler numbers of prime numbers will become what? 1 less than that value. 1 less than that value. If you want to find the Euler number for normal numbers, this is the process. This is the process. Understood, students? For Euler number of prime numbers will become those numbers only. 1 less than that numbers. The Euler number of normal numbers means this is the process to find the Euler number of normal numbers. Normal numbers. Understood? Now come to our case. Right? Understood? A comma B should be co-primes, and next P should be the multiple of Euler number of B. That means this P should be the multiple of Euler number of B. Now come to our given question. What is our question here? 2 to the power of 83 by 83. What is the remainder for this? With the general understanding of our remainder theorem, we will not get the answer for this. But with the help of Euler number, we will get the answer for these students. Please observe here. 2 and 83 are what? 2 and 83 are co-primes. 2 and 83 are co-primes. And next one more advantage is here, directly 83 is a prime number. 83 is a prime number. So what I will do is, intentionally I will write in this manner. 2 to the power of 82 into 2 to the power of 1 by 83. 2 to the power of 1 by 83. Now 83 is a prime number. 83 is a prime number. So what is Euler number of 83? 82. And 82 is a multiple of 82. 82 ones are 82. So that means the remainder for 2 power 82 by 83 will become what? 1 into 2 by 83 is 2 only. So the answer will become what for us here? 2. Understood, students? The Euler's remainder concept. From the help of Euler's remainder concept, we will solve the answer in this manner. Understood? See students, nowadays the latest trend of questions is based on this Euler's numbers only, and that too the denominator will be prime number. If it is not a prime number also, you can solve it with the help of Euler's number, but if it is a prime number, you can tell the Euler number very quickly, right? You can tell the Euler number very quickly. Okay, now similarly tell me, what is the remainder for 3 to the power of 98 by 97. 3 to the power of 98 by 97. 97 is a prime number. 97 is a prime number. And 3 and 97 are co-primes. 3 and 97 are co-primes. Now please observe here, if these two are co-primes and 97 is a prime number, luckily, there is no rule that it should become a prime number, but if it is a prime number, it will be easy for us. So what is Euler number of 97? 96. So what I will do is, intentionally I will write it as 3 to the power of 96 into 3 square by 97. 3 square by 97. The remainder for this will become what? 1 from the Euler's concept. From the Euler's concept it becomes 1 into 3 square will become what? 9. 9 by 97 is 9 only. Remainder for 9 by 97 is 9 only. So the answer will become what for me here? 9. The answer will become what for me here? 9. In this manner, we will take the help of Euler's remainder to get our answers. Understood students? Now we will solve one example based on this. Right. What is the remainder when the number 4 to the power of 4 fourths to the power of 4 fourths is divisible by 9? Is divisible by 9. Okay. Now we will see. In general, we will see. First of all, 4 fourths by 9. What is the remainder we will get? Forget about the power. For instance, 4 fourths by 9. What is the remainder? We will see in a general manner, and we will take the help of Euler's remainder. We will try to get the answers for both of them. Okay. Anyway, the general method also, anyway, we will come back to the Euler one only. That is the reason. Next, 4 fourths to the power of 4. So, first of all, I am dividing this 4 fourths with 9. With 9. What is the remainder I will observe? 9 4s are 36. I will be left with how much? 8. It will become 84. 9 9s are 81. I will be left with 3 and 4, 34. 9 3s are 27. I will be left with what? 7. So, this one will become what? 7 to the power of 4 fourths by 9. Understood students? 7 to the power of 4 fourths by 9. Why? Because the remainder is what it becoming? 7. 4 fourths by 9, the remainder becomes 7. So, directly I will take 7 to the power of 4 fourths by 9. Instead of 4 fourths, that is eliminated. Now, 7 and 9 are what? 7 and 9 are what? Co-primes. Am I correct? 7 and 9 are co-primes. And now, what is the Euler number of 9? 9 can be written as what? 9 can be written as 3 square. So, Euler number of 9 will become 9 into 1 minus 1 by 3. And because only 3 is there, right? So, what happens to this? 9 into 2 by 3. So, 3 ones 3 3s. So, the Euler number of 9 is what? 6. So, 4 fourths should be written in the multiple of 6. So, tell me what is the multiple when I divide 4 fourths with 6, what is the remainder I will get? 4 fourths by 6. What I can write this one? How I can split this one? 4 fourths I need to divide it with 6. Why? Because I need to write as a multiple of 6. 6 and 4 fourths. 4 sevens are 42. 2 and this 4 will come here. Am I correct? 6 4s are 24. Okay. The remainder what you will get here is 4 only. If you go with the zeros or without 0 also, you will get the same remainder 4. You will get the same remainder 4 for us here. Okay. Right. So, you will get the remainder as 4. That means what I can write this 7 to the power of 740. 7 to the power of 740, or else 7 to the power of 6. 6 into 740. 6 into 740 into 7 to the power of 4 by 7 to the power of 4 by 9. 7 to the power of 4 by 9. Now, the remainder for this is what? 1 from the Euler's concept. 9, Euler number is 6. So, 6 into 740 will be a multiple of 6 into 7 to the power of 4 by 9. 7 to the power of 4 by 9. 7 to the power of 4 by 9. So, 7 to the power of 4 by 9, you can solve it or you can do in any other manner, but my suggestion is directly solve for 7 to the power of 4 by 9. You will get the answer. 7 to the power of 4 means what you will write? 49 into 49 by 9. 49 into 49 by 9. 7 square into 7 square. So now what happens? What is the remainder for this? 4. What is the remainder for this? 4. 4 4s are 16. 16 by 9. 16 by 9. Don't get confused. Once again, 16 by 9, what is the remainder? We will get 7. So if you take the help of Euler's remainder, you will get the answer very quickly and effectively. Intentionally, I have written this as 6 into 740. Why I have written it in the multiples of 6 into 740 means the Euler number of 9 is 6. 6. So if you know the Euler number, if you know the Euler's concept or Euler's remainder, then easily you will get the answers. So for that, we should have two principles. A to the power of p by b, already I have written, but once again I am writing. What it is, first rule is a comma b should be coprimes. A comma b should be coprimes, and the second one is p should be multiple of Euler number of b. P should be multiple of Euler number of b. If it satisfies this condition, then we can say that these two numbers are coprimes. Sorry, the remainder will be 1. The remainder is 1. The remainder will be 1, always 1. Okay, with the help of Euler's remainder, you will get the answers very effectively and quickly, students. So try to understand this Euler's remainder. Okay, so with this we finished all the questions of, concepts from, basic concepts from the number system. In our next session, we will directly start solving the questions from this number system. It may be units, digit, zeros, remainders, factors, and all the other different types of questions based on numbers, types of numbers, and the statement based questions. We will see some important questions and as well as the previous year's questions which was asked in the CSAT paper. So these are the basic concepts which we should know before solving those questions, students. Right? That's it for today. We will see in other session the remaining questions. Thank you very much. Thank you.